Hello class, I thought I would do a problem from section 12.6. The reason I'm doing this because the textbook and the directions would like you to do this problem in a very difficult and time-consuming process, and I want to use the power of our calculator to quickly come up with a solution to this particular problem. So 12.6 is linear correlation, finding the linear correlation coefficient, and also finding a linear or a straight line best fit for the data. So this is very similar to what we covered in chapter 7 with linear systems. In one variable we have minutes shirtless in this particular example, and as the x variable, and the y variable is opening weekend gross in millions of dollars. And so the x variable is going to be time, and the y variable is going to be how much money that particular movie made. And so since they tell me that x is this particular column here, and the y variable is this column on the right, I'm going to immediately enter those as lists. So my x list will be list 1, the y list will be list 2. So I'm going to go and hit stat on my calculator, edit, and list 1 will be the x values, list 2 will be the y values. Now I already have two lists in here, so I want to make sure to clear those. So I'm going to arrow up till I bold list 1, and then hit clear, and then enter. And I might as well do that for list 2 as well. Highlight list 2, clear, and then enter. And so now I have a clear slate for each list, and I'm going to enter these numbers here for x. So I've got 0, 0.6, 1.8, 2.2, and 13.7, and these are in minutes. All right, so I should have 5 data points, 1, 2, 3, 4, 5. And if you notice on the calculator, it says the next entry would be entry 6. So now I'm going to make sure that I pair with the X list everything in the Y list. So 0 minutes is going to correspond to 6.1 millions of dollars. So I'll enter that in, and I'll just keep working my way down that column on the right. 7.9, 16.8, 17.4, and 22.7. Notice that the two lists are the same length. If you don't have them the same length, then your calculator won't be able to compute a correlation coefficient, because they have to have, for every x, there has to be a y. Now it says it wants the correlation coefficient, and if you were not to use the calculator and you hit question help, it would give you this very long, drawn out formula for the correlation coefficient. You know, n times the sum of x times y minus the sum of the x's times the sum of the y's, all of that divided by, and it's just huge, really time-consuming and very painful calculation to do correctly. And so since we have technology, there's no reason why we can't just use the technology. So back to our problem. Oh, it changed the numbers on me, so I guess I shouldn't have done that. So let me quickly change these up. 0.7, 1.2, 2.1, luckily there's only 5, and 13.9. And for the other ones, 5.6, 7.9, 16.8. Oh, that's the same, I guess. 17.5. And lastly, 20.6. Okay. So now, if I hit Stat, Calculate, now we did use this before in Chapter 7. Now notice I can have linear regression, quadratic regression, cubic regression, quartic regression, linear regression. Now it does repeat itself. I'm going to pick the first linear regression, option 4. Now if I select that by hitting Enter, list 1 and list 2, and I want to store the equation that I get into a variable. So I'm going to hit Variables. I want the Y variable. I'll hit Enter, and I'll just store it into Y1. So now the equation that it's going to come up with will be stored in Y1. So I'll calculate. And so here, the linear regression equation is going to be y equals 0.767x. That's the A. The A is 0.767 to 3 decimals. X plus 10.934. So notice it does not give me R. It only gives me the coefficient A on the variable X and the y-intercept B. Now the problem wants R. And as it sits, does not give me R. So I can force the calculator to give me the correlation coefficient. I do have to go to the mode section of my calculator, and a little bit more than halfway down it says Stat Diagnostics, and they're turned off. So again, I hit the mode button on the calculator, and I want to turn the diagnostics for my statistics on. So I'm going to arrow down and turn this on. Now some of us, if we have an older calculator, this is not a menu item when you hit mode. So if that's not the case, hopefully it is, then if that's not the case, you have to go, I'll exit out of here, you have to go to the catalog function, which is in little blue writing. It's second, the number 0 gives me the catalog function. Maybe I'll enlarge this a little bit. So second catalog, and you literally have to arrow down until you get to the word diagnostic. So I'm just going to hold down the cursor until I get to D. And there's diagnostic on. So I'll select that. Notice the arrows on that. And I'll hit Enter. And now I've forced the calculator to turn on the diagnostics. So hopefully you don't have to do this. You just go to Mode, go to Stat, Diagnostics, and switch this to on. Once that's done, I'll hit Second Quit. If I hit Stat, Calc, Option 4, which is Linear Regression, and now when I hit List 1, List 2 for my X and Y, again I'll store this for Y1, so I'll hit the variables key, Y variable, and I'll just hit Enter. And Enter again, and now I'm going to store the equation into Y1. Now when I calculate this, it gives me R. It also gives me A, 0.767 like we had before, and B. But now this R helps us answer this question here. And 0.68, they want 2 decimals, so 0.682. And there's 2 decimals. The 2 does not change the 8. So I'll check answer, and it says good job. Now, if we did not do this on the calculator, it might have taken me by hand, a half hour to do this. So we definitely want to use the calculator. So y equals, and they want this to 2 decimals. So y equals, the coefficient in front of the x is a, which is 0.767, so I'm going to round to 0.77. And the y-intercept, that's the b, 10.93 to 2 decimals. And I'll hit Enter, and excellent. So what opening weekend gross can we anticipate in a film in which the actor appears shirtless for 18 minutes? Okay, so now I'm going to back up a little bit. I would like to look at the plot of this data. So I'm going to go to second stat plot. So second stat plot, it's up here. It's the y equals button. And I'm going to select plot 1. And the scatter plot is the first possible option. And again, that's already been selected here. List 1, list 2, that's the x's and the y. And now to get the perfect window, I'm going to hit zoom 9. Zoom 9. There's the scatter plot, and there's the line that I saved into Y1. Okay, so now I want to make a prediction for when it's 18 minutes. So I'm going to hit second table set, and I want to have the independent variable, meaning x variable. I want that to be asked. So I hit second table set or the window button. I'm going to switch the independent to ask. And now when I go to second table, instead of a graph, it's going to make an XY table. And the problem wanted 18 minutes. So for 18 minutes, the prediction will be $24.74 million. So this wants one decimal place. So $27.4 million. Okay, so did I not enter that in correctly? 24.74. It should be. Oh, you know, I think my dyslexia has got the best of me. That's 24.7, and I wrote 27.4. So occasionally I transpose numbers. So even a mathematician, you can have problems seeing. So a little bit embarrassing, but it does show me that, or you, that I can make simple mistakes. So there we go, and now we've got fantastic. So please use this video to complete 12.6 number 7 and 8. Otherwise, if you do not, it will be a very, very lengthy process. So good luck, and I will see you later.